One of the limitations of conventional zero-shot prompting method is that it gives good results for simple tasks, but could be better for solving complex tasks involving multiple steps and reasoning. For example, let's consider the task of writing a blog post, which can be broken down into multiple steps like researching the topic from credible sources, creating blog outline with headings and subsections, writing initial draft, analyzing, critiquing, and improving the initial draft, proofreading, and editing to generate the high quality content. Asking LLM to write complete blog posts about given topic with a single prompt might not yield best results. Instead, planning for each subtask and giving them to individual LLMs who can interact with one another to complete the task can produce high quality results. This iterative and multi-step process of instructing LLMs to solve complex tasks with high accuracy is called agentic workflow. Various research has shown that the accuracy of response generated by agentic apps is quite higher than the traditional zero-shot prompting response. To simplify the implementation of agentic workflows, the LangChain team created a Python library named LangGraph. LangGraph is an extension of LangChain that lets us implement agentic workflows as directed graphs. In this video, I will guide you on the step-by-step process of building a React agent workflow, which is based on the thought, action, observation loop using LangGraph. The tutorial is a good starting point for someone new to LangGraph. The agent will use the available tools to retrieve financial data about given stocks to answer user queries. We will use open source LLM Llama 3.1 available through Groq API as our agent's decision making and response generating LLM. So without further ado, let's get started with the coding part. Alright, so I have kept the total code for this tutorial in this Jupyter notebook. I will include link to it into the description so you can download and follow along. At the beginning of the notebook, I have included a sample image of what a React agent look like. So whenever user query comes in through question, it goes into this thought, action and observation loop to solve that user query. First, it thinks how to solve that query. And for solving that query, it might need to call list of tools. It might need to call single tool or multiple tools. And that happens in the action stage. And the response that goes to the observation stage. So observation has a response from the tool calls. And based on that observation, the LLM decides whether to return, whether if it has enough information to answer user query. If it has, then it returns. Otherwise, it again goes into the thought, action and observation loop where it calls more tools to answer user query. For our case, I have written various finance tools that can be used to retrieve the latest details about any stocks like their total debt, total revenue, debt to equity ratio, EBI TDA and so on. Next, I have highlighted the important sections of this tutorial. So first of all, we will load our LLM, which we will access to Groq API, and the LLM is Llama 3.1. Then we will define various finance tools. Then we will bind these tools with LLM. So every time the LLM is called, these tool details will be passed and LLM will decide which tools to call. Then we will define our React agent using LangGraph. And in the last section, we will query our agent with various queries to see how it's performing. So first of all, over here in this cell, I am loading environment variables. So for that, I am using load environment variable function from .env. And I have kept the environment variables in .env file in the current directory. So from there, I am loading the Groq API key. So in this first section, we are loading our LLM. And as I said, we will access our LLM through Groq API. For that, you need to log into this URL console.groq.com and create an API key. Then you will be able to access various LLMs through Groq API. Next, I have highlighted the important models which are available, the various LLMs available through Groq API. For this tutorial, I will be using Llama 3.1 70 billion version. There are also other LLMs available which you can try if you're interested. The Llama 3 Groq 70 billion tool use preview So this one is this and the next one, these two are specifically fine-tuned for tool use. So if you're interested, you can use them as well. Now, in order to access Groq API through LangChain, you will need to install this module LangChain Groq. So once you install that module, you should be able to import this class chatGroq from it. And then we create an instance of that class chatGroq where we provide the Groq API key as the API key. And the model, I have set it to Llama 3.1 70 billion versatile. So this model I have set. And this will create an instance of chatGroq. So that's our LLM. So once we have created an instance of LLM, we can query it by calling this .invoke method it, and over there we can provide any query. So I have asked simple question, hello, how are you, Llama 3.1? And the response from the LLM is an AI message, an object of type AI message, where there is an attribute contained where the response from the LLM is present. And here is the response. I am doing well. Thanks for asking. I am a large language model, so I don't have emotions, and so on. So that's how you can load LLM and then query it. So in the second section, I have defined various tools which will be used by our LLM to retrieve the latest financial details about any stock ticker. And for that, I have imported this tool decorator from LangChain core.tools. And we can decorate any function with this tool decorator, and that function will be turned into LangChain tool. And the type of that tool will be structure tool. And next I have imported a library, Python library Yahoo Finance as YF. And this library we will use to retrieve the latest detail about any stock tickers. So the first tool that I have declared is company address. And as you can see, I have decorated with add tool. And this tool takes as input a single argument ticker, which can be stock ticker. So if the company is Apple, then the stock ticker will be AAPL. For Microsoft, it will be MSFT and so on. Then I have declared a doc. This doc explains that what is the usage of this function, how to use it, and what it returns, and so on. And including this doc details is important because this detail will be passed down to LLM, and the LLM will use this detail to decide which tool to call. So properly define this detail. So once we have specified that docs from Yahoo Finance, I am calling this class.ticker, and over there I am providing our ticker, input ticker from the method, which can be AAPL, MSFT, and so on. And this will create an instance of ticker object, and this is a Yahoo Finance ticker object. And this ticker object has a method named getInfo. So when you call this method, it returns you a very big dictionary, and that dictionary has a lot of information like the address, city, state, about that particular stock ticker, the employees, the last close price, total debt, revenue, and so on. A lot of information is available. So from that dictionary, I am retrieving these keys. So address, one, city, state, zip, and country. I am looping through those keys and retrieving those keys values from the dictionary and then joining all of them with space. So this will return me a single string, and that string will have the total address of that particular input ticker. So that's our first tool. Now all our other tools have almost same structure. So next tool is a full-time employees, and that also takes as input ticker. And then there is a doc string. Again, I have created an instance of ticker object and called the getInfo method on it. And in this info method, info dictionary, there is a key name full-time employees, and that will return me the count of full-time employees for this particular ticker. So that's our full-time employees ticker. Same way, I have declared another tool, last close price. This will be used to retrieve the what is the last close price of the ticker. So same way, define doc, it takes as input ticker, define ticker object, getInfo, and in this info dictionary, there is a key name previous close, which can be used to retrieve the last close price of the particular input ticker. Next is the tool for retrieving the EBI TDA. So it has same structure as our previous tools. We retrieve the info dictionary, and in this info dictionary, there is a key name EBI TDA, which we can use to retrieve the EBI TDA of the input stock. Same way, there are next three tools, total depth. So total depth will be used to retrieve the total depth of the input ticker, and that is also available through info dictionary. And same way we can retrieve the total revenue through total revenue key of the info dictionary. And debt to equity ratio is available through debt to equity key of the info dictionary. So after defining all these tools individually, I have maintained them over here as a list. So this tools variable has a all list of tools. So in this third section, I am explaining that how you can bind tools with LLM. So next time you query LLM, it will decide whether it needs to use any tool to answer query and or not. So for that, you can call this method bind tools on our chat Groq instance, which is Llama 3. And over there, you can provide tools. So next time, and it will return chat Groq instance again. So the Llama 3 with tools is now an LLM with tools. And if you call this LLM, then it will pass the details of the tools as well. Now there is a parameter named tool choice, which I have set to auto. So what this parameter will do is that if LLM needs to answer some query and if it needs to use tools, then it will use tool. But sometimes it might not need to call any tool to answer query. So then it won't use any tool. So this auto lets us decide whether it needs to use tool or not. There is also another value any, then the tool call will be forced. So it will force LLM to call some tool. And in some situation, you might not want to call tools. So once you declare LLM with tools, you can again invoke it by query it by calling this invoke method. And I have called this, I have given this query like what's up, and the response is an AI message. And now the AI message.content is the response, as you can see. But now with this LLM with tools, there is a new attribute named tool calls available. And if LLM has to call any tools, then those tool calls will be available as a list of dictionaries over here. And these tool calls are important. So in the next cell, I have again called our LLM. And this time I have asked it a question like, what is the EBI TDA of Microsoft? And EBI TDA is available as one of our tools. So now the response from AI message, as you can see, the content this time is empty. As you can see, there is nothing getting printed over here because it's an empty string. But if you look at the tool calls, it's a list. And that list has a one dictionary where the name of the tool is mentioned and what arguments should be passed to that tool, that is also present. So for Microsoft, it was able to retrieve the ticker MSFT. So it is suggesting us this time that we should call this tool to answer this query. And this kind of information is important for us because when we called it with this kind of query, the tool call was empty. But when we called with this query where the tool call was needed, it returned the tool calls as a list of dictionaries. And this will be needed when we create our LangGraph graph to make decisions, because the decisions will be based on whether any tool call is available or not. So in the next cell, I have invoked our tool EBI TDA by calling this method dot invoke on it. And over there, I have passed this args, which is over here, this ticker MSFT. And the tool call returned with this response, which is the EBI TDA of the Microsoft. So now that we have loaded our LLM and defined tools, we can define our React agent using LangGraph. But first of all, let me explain you a few concepts. So over here in this image, I have highlighted few important components of the LangGraph graph. And as I said, LangGraph graphs are directed graphs. So there are nodes and there are edges. So nodes are generally agents or any function call, and agents can be LLM as well. So those LLM executions and function executions will happen to these particular nodes. Then there are edges. So edges will be used to connect this node, and the edges will be responsible for the control flow. So after we have executed particular agent available through this node or LLM or function, which next node it should transfer control to, or whether it should return from the graph and so on. So that will happen through edges. And there is a special kind of edge available, which is called conditional edges. And this kind of edges are important for making decisions. So sometimes the response from the nodes can be multiple string or multiple responses, and you might want to direct to different nodes based on the response from that particular node. So if response is true, then you want to direct to some other node, and if response is false, then you might want to direct to some other node. And that kind of direction can happen with the conditional edges. So those are the important components. And here is the image of the React agent which we are going to create. So our agent has two nodes, Llama 3 and action. And this is the starting point of our agent. So the first time the agent will be called, the Llama 3 node will be invoked. And the Llama 3 node response will go through this method name access action. And that access action method checks whether there is any tool call or not. And as I explained earlier, if you remember this part where there was no tool call, and in this call, this query call, as you can see, there were calls, there were tool calls. So this access action function from Llama 3 will check whether there is any tool call or not. If there is a tool call, then it will go to action node. If not, then it will return from the chart or return from the graph. And then once there are tool calls, the control flow will go to action node, and there is a method named take action, and this take action method will execute all the tool calls. And after all the tool calls are executed, the control flow will again go back to Llama 3. Now Llama 3 will check that whether it can answer the user query based on this tool call responses. If it can, then the access action will return false because the response will be present and there won't be any more tool calls. But if it needs to call more tools to answer user query, then there will be tool calls present and access action will return true, and then again it will go into this loop. So it will go into this loop of Llama 3 to action or from true as many times it needs to execute tools. So that's the graph of our React agent. Now let me explain you how to implement it using LangGraph. So for that, I have few imports over here at the beginning. So from LangGraph.graph, I'm importing this class stateGraph, and this will be used to create an instance of LangGraph graph. And then there is a end. So this kind of a node where the control flow will end from the chart. Then from typing, I have imported type, dict, and annotated. So this will be used to create an agent state. Then I have imported operator, and that will be used as well. And from langchain code.messages, I have imported this message type, any message, system message, human message, and tool message. So these are different types of messages which are generated by human, tool, or any system message. So first of all, over here, I have declared a class named agent state. So this agent state class is responsible for managing agent state at any point of time. And for our case, we are creating a simple dictionary to maintain agent states, and that dictionary will have a single key messages, and the value of that key will be list of messages. So any message can be used to represent any message, system message, human message, tool message, or AI message. So the value of that key is a list of messages. And then I have annotated that list of messages with this operator.add. So anytime a new value is assigned to messages key, that value will be appended at the end of the existing list. So initially our chat history, so this agent state will be used to maintain chat history, but you can maintain any other details as well in this agent state. So initially it will start with this empty list. And over the time, as the user message come in, it will be appended as a human message, and the response from AI will be appended as AI message. Then tool messages will be appended as well. So this agent state is used to maintain the graph's state at given point of time. And this state is available at all the nodes and edges of the graph. So you can access it in any method of the graph. And for creating this dictionary, I have extended agent type dict class to create agent state. So next, I have declared a class to define our agent. And first of all, over here, we are initializing our agent. So For that, this init method takes three arguments: model, which will be our LLM, tools, which is the list of tools, and if there is any system message. So first of all, the system message is assigned to self.system, and in this self.tools, I am maintaining a dictionary which is mapping from the name of the tool to the tool itself. So I'm looping through tool and then creating this dictionary which is mapping from tool name to tool. And for model, self.model, I'm maintaining model.bind tools. So this I explained earlier, that how you can bind the tools to LLM. So this new LLM will have tool details as well. So that we are maintaining as a self.model. Now next few lines of code will be used to create our graph, LangGraph graph. So first of all, I am creating a graph variable where I am creating an instance of state graph. And there we are passing this class agent state. So this agent state will be initialized initially with object. And as I said, it will be available through all the nodes of the graph. So after we have created an empty graph, we can add nodes to it. And we will add two nodes of our graph, Llama-3 and action. If you remember, our graph has two nodes, Llama-3 and action. So we can add node by calling this method add_node. And the first argument is the name of the node, which is Llama-3 in our case. And the second argument is the function or method which you will execute when the control flow will go through this particular node. So for the first node, Llama-3, we are calling this function called LLM. So let me show you this function. So that function is defined over here as a call LLM. And as you can see, that function takes only one argument, which is state. And as I said, the state is available at all the nodes and edges of the graph. And as you can see, its type is agent state. And if you remember, the agent state is a dictionary with only one key, messages, where the list of messages are available. So call LLM method, first we retrieve the list of messages. So this messages variable has list of messages. So initially it will be empty. And then we check if there is any system message, then we will prepend it. So we will prepend it to our messages. So now messages will have system messages if there is any present. And then we invoke our model. So our self.model is model with tools. And then we invoke it with this list of messages. And then the response from that will be the response from LLM. So for the first time, this messages will only be a human message, will be a simple user query. So then the system message and user query will be passed to LLM, and the response from the LLM will be the AI message. And that message will go over here. So as you can see from here, we are returning a dictionary messages with only one message. So this AI message will be appended to our history. So first the human message will be appended, and then the response from AI, this AI message will be appended. So that's our call LLM method. So that's our first node. The second node that we are adding is action node, and that is handled through take action method. So here is the take action method, as you can see. And again, that method takes as input the state. And for executing this particular method, first of all, from list of messages, we are retrieving the last message. So if you remember, after calling the LLM, the history will have last message, which will be of type AI message. And from there, the tool calls will be present. So if LLM needs tool calls to answer user query, then there will be a tool calls attribute, and it will have a list of tool calls. So in this loop, I am executing those tool calls and maintaining the response in this results list. So I'm looping through each tool call, and there is a if else condition. So if there is a wrong tool name, then that will be printed. But if there is a right tool name, then we execute that tool. So from self.tools, which is a dictionary, we retrieve the tool name. So based on the tool name, that tool will be retrieved. And then we call the .invoke method on it with the T of args. And that will be the response from the tool. And then we create an instance of a tool message, which will have tool call ID, the name of the tool, and the response of executing the tool will be present as content. So this results list, which we are maintaining, it will have a list of tool messages. If there is only one tool call, then there will be only one tool message, else there will be a multiple tool messages. And that we are returning from here as a dictionary. So messages with results, and results is a list of tool message. And this results of tool message will again append it to our agent stage, which is the history. So first of all, the human message will be appended, then this AI message will be appended, and then this list of tool messages will be appended. So that's our action node. So now that we have added the two nodes, now we need to add the conditional age, this conditional age, which we have defined over here. And this will decide from Llama-3 whether go to action or whether return from graph. So for that, we will call this method add conditional age on the graph. And input to this method first is the source node from where the condition will start. And what particular function to execute, particular function or method to execute to handle for this particular conditional age. And the response from this particular action will decide that where we want to transfer control to. So for that we define a dictionary. And as you can see, this access action function returns two values, true or false in our case. If it returns true, then we go to the action node, which we have defined over here. And if it false, then we return and. So we go out of the chart. So that access action function I have defined over here. And again, as you can see, this method has a state available. So from state of messages, we retrieve the last particular message. And from that message, we check for tool calls. So after call to LLM is happened, so last message will be the AI message after first query we have called the LLM. And that will be available from messages. That will be available over here. And that will go to access action. So from that, we check for tool calls. So if there are tool calls available, so length of tool calls is greater than 0, then this method will return true. Else it will return false. So that's what happens over here. So after Llama-3 node is executed call LLM, the conditional age will decide whether go to action or whether return from chat. If there are tools calls, then it will go to action, otherwise it will return from chat. So that's our graph. Now before I end, I need to add one more important age. So that age is from action to Llama-3. So after we have executed this action, take action class, this one, the take action method, this will execute list of tools and append the response as a tool message to our chat history. So after that, we need to pass control flow back to Llama-3. And Llama-3, based on that response after tool, will generate the response. So again, from here, we need to go over here. And based on the tool response and complete history, the Llama-3 will then generate the response. And for that, it might generate the response and return. Otherwise, if it needs to call more tool, then again it will add the tool calls. So again, it will go into this loop. So that's why this age is needed from action to Llama-3. And then at the end, we need to set the entry point for our graph. So which is the first node which will be executed when we invoke our graph. And that's what we are doing over here. We are setting the entry point as Llama-3. So once we have defined our complete graph, we can compile it and store it in this self.graph attribute of our class React agent. So that's our React agent. So once we have defined our React agent, we can create an instance of our agent. So first of all, I have defined a simple system message. So you are a smart AI finance assistant. Use the list of tools available to answer questions if needed. And you are allowed to make multiple calls either together or in sequence. So when creating React agent, I am passing the original Llama-3, and to this we will call the bind tools over here. You can see over here bind tools is called. Then I am passing list of tool, and then I am also passing system message. So that's our agent. And next we will invoke this agent with various query. But if you want to visualize this agent, so you need to install this Python library PyGraphBase. And then you can call this method getGraph on the graph object, which will return an instance of graph. And there is a method named drawPNG, which you can call, and that will create a PNG and in the temporary directory and return it. So then you can visualize this graph that you have created. And as you can see, this is the graph created. And if you look closely at this graph looks exactly like the one which I explained earlier, our original graph. As you can see, there is a starting point, and from Llama 3 there is a condition. Based on true, it will go to action. False, it will return from graph, and so on. So that's our agent. So now that we have defined our agent and initialized it, let's go ahead and try various queries through it. So first of all, as you can see, I have created this messages variable with the list of messages. So if you want to send any query to our agent, you need to create an instance of human message, and there as a content attribute, you can specify the query. So for the first time, I am asking it some random query that what's up Llama 3.1. And as you can understand from the query, it will not need to execute any tool call for answering this query. And to send this query to LLM, we need to call agent.graph, and then on that we need to call this method .invoke. Over there, we provide this dictionary, which is the agent state, initial agent state, if you remember, with only one key messages, and the value is the list of messages. So first, initially, it will be the only human message, and then there will be response from this graph. And as you can see, response will be the agent state. And if you go to the list of messages of that agent state of -1, so the last one this time will be the AI message. If you check the content of it, it's string. So as you can see, not much, just here and ready to help with any questions or tasks you have. What's on your mind? So as you can see, for the first time, it did not need to execute any tool call, because if you go through the code of the tool calls over here, we have a few print statements over here which are specifying that which tool call is happening and when the tool call execution is complete. So this print message are not printed, which means that there was not any call to any tool. So let's go ahead and try one more query where we will need to use tool. So next, I have again defined a human message with only single list, and the query that I am asking is what is the EBI TDA of NVIDIA? And again, we have invoked our graph with that messages and result. So here is the result. And as you can see, this time it printed few messages. So first it printed that calling this tool, and it printed over here that it needs to call this tool EBI TDA, and arguments are this ticker and NVDA. And after execution of this tool, it returned that tool execution complete back to model. Because to answer this query, we need to call only one tool. And if I print result over here, so if you see, result is a dictionary message, and there are list of messages. So the first one is the human message which we passed. Second one is the AI message, and in this AI message, as you can see, content is empty. So take action method will return true because there are tool calls. If you can see over here, there are tool calls, and there is call to this EBITEDA tool. So after this AI message, there is a tool message, and this tool message is the execution of tool. So name of the tool, and this is the content is the response. So this is the EBITDA of NVIDIA, which we got from the call of this tool. And after this tool message, again the control flow will be passed to Llama 3, and that generated this AI message response. Say that the EBITDA of NVIDIA is this. And as you can see, there won't be any tool call anymore because it has enough information to answer the query. And we can retrieve that from the last message as well. The last message is the AI message, and it returned from the graph. Yeah, so this is the total history of this particular interaction with the agent. So let's go ahead and try one more query where the agent will need to execute more than one tools. Now in this case, it will execute tools one after another, but it can happen that it executes for one tool, then go through LLM again and generate some response, and again then it goes back to tools. So for this one, as you can see, what is the EBI, TDA and debt to equity ratio of Google? So that's our query. And then I have invoked our graph with that message. And as you can see, this time it called two tools. So first one is the EBI TDA tool, and the arguments is ticker with GOOG. So this is the ticker of Google, which our LLM was able to retrieve. And then it retrieved debt to equity ratio tool, and they executed that tool with argument GOOG. And after execution, it's printed that tool execution complete and back to model. And from results of messages of -1, if I print the content, you can see the response. So the last one will be the AI message, just like this one. And there will be two entries for tool message this time. One will be for EBI TDA and one will be for debt to equity ratio for Google. So based on the tool call results, the EBI TDA of Google is this $115 billion, around 115 billion. And the debt to equity ratio is 8.295. So when you execute this code, you can print this result and check the responses of the tool calls to verify this response. So let's go ahead and try one more query. So over here, I have asked that compare the total revenue of Apple and Nvidia. So for that, again, as you can see, I invoke graph, and there are two tool calls. So the first tool call is to total revenue, and the ticker is AAPL, which is the ticker for Apple. And the second call is again to total revenue, but this time the ticker is NVDA, which is the ticker of NVIDIA. And then the tool execution is complete. And after that, there is the control flow will go back to LLM, and the last message will be the AI message, which is the response from our tool, response from our LLM. So as you can see from the response, that based on the result, Apple's total revenue is this, which is around $381 billion, while Nvidia's total revenue is this, which is around $79 billion. And the LLM is saying that Apple's total revenue is approximately 4.8 times larger than Nvidia's. Yeah, so based on the tool calls, it retrieved the total revenues, and then it compared it, and it deduced that the revenue of Apple is 4.8 times of that of Nvidia's. Alright, so that's how you can create an agent using LangGraph. If you have any doubts or any question, then please feel free to let me know in the comment section, and see you next time.